Okay, Assalamualaikum. Right, we shall try paper 2002, question 4. Okay, the question about cupcakes. Right, so basically, Charlotte decides to model the shape of a cupcake to calculate its volume. Okay, and then what Charlotte did is she rotate 90 degrees. Okay, make it like a vertical cupcake kind of thing. And then there are some points that the cupcake actually coincide lah. Okay, some coordinates over there. Okay, first one is she models the section 03.5 to 46. Okay, there's this like upward punya line kind of thing. Okay, she models that as a straight line, and then find the equation of the line passing through these 2 points. Okay, so this one I'll go through very fast. So first we need to find the gradient first. Okay, using the 2 points, so I'll just put in the number line, y1 minus y2, which is this, divided by 4 minus 0. Okay, after you get the gradient, you will need to use this, y1 minus y minus y1 equals to m x minus x1. Okay, that will give you the equation of the line. Okay, where this one you substitute the point 46 kalau balik. Right? Okay, so this one the answer key dah tulis. Okay, so it should be quite fast and everybody should be able to get it. Okay, right. The next one is on regression, if I'm not wrong. Okay, so Charlotte models the section of the cupcake that passes through the points as such as a quadratic curve. Okay, find the equation of the least squares. So the B part 1 is actually purely GDC. So you key into your GDC, you should be able to get the equation as y equals to negative 0.975 x squared plus 9.56 x and then minus 16.7. Okay. The next question is the thinking question. They say by considering the gradient of the curve at x equals to 4, explain why it may not be a good model. Okay, so you want to get the gradient of the curve, right? Because this one is only the equation. Okay, so if you really want to get the gradient of the curve, for this one, because it's only one mark, okay, you can actually see from the equation itself, okay, and see that at x equals to 4, the gradient is actually positive. Okay, so you don't really need to calculate the gradient. Okay, you just observe and then make sure that you are able to see that the gradient is positive. Okay, so if the gradient is positive, it's not what we want. That means if it's positive, right, that means it's always going up and up and up. Okay, so it doesn't make sense. You want it to be going downwards, right? Okay, so because the gradient is positive, that's why this model is not an appropriate model. Okay, or may not be a good model. Okay, the next question. Charlotte thinks that a quadratic with a maximum point of 4,6. Okay, that means that dia punya maximum point is at the part yang dia punya cake tu terkeluar sikit lah. Dia punya ujung dia. Okay, 4,6. Okay. And then passes through 7.50 would be a better fit. Okay, so 7.50 is not in the diagram. Okay, 7.50. Basically 7.50 should be, oh yeah, it's on the diagram cuma dia tak tulis. Okay, it's the part where it lands on the x-axis. Okay, the x-intercept lah. Okay, so we need to find a quadratic model that lands there. Okay, highest is at the 4,6, okay, and then lands at the 7.50. Okay, so find the equation of the new model. Okay, so this one there's a lot of ways to do. Okay, one is if you know that the, let me erase this first. Okay, if you know that the maximum point is at 4,6, okay, one of the ways is you can do like this: y equals to a bracket x minus 4. Then square, lepas tu plus 6. Okay, this is the x minus h plus k. Okay, format. Okay, but do remember that you must put an a here because we don't know what is the a value here. It can be a 2x square, x square or something like that. So we need to put the a. So your next step will be substitute the next point that they give, which is 7.50, okay, into this equation. Okay, so that you can get the a. Okay, that's just one way to solve lah. Okay, there's one interesting way that they suggested. Okay, dia macam ni tau. Okay, dia cakap, okay, this is the thing. You want it to land here at 7.5, okay, and you want it to be at the height of here, which is like 4.6. Okay, so that means dekat sini kan, sini is 4. Okay, so the curve will be like that, turn, then go down. Okay, so that means if from here to here is a distance of berapa? Like 3.5. Okay, that means from here to here it must be 3.5 backwards. So that means is 0.5. Okay, so now you have 3 points, satu kat sini. Okay, 0.5, 0. Okay, you have satu kat sini atas ni, and satu kat sini. Okay, so if you have 3 points, you should be able to use quadratic relation to get the equation up. Okay, so that's the other way. Okay, because we know it's quadratic kan, 3 point je. Okay, if we don't know yet, then we need more points up. But now they say we want a quadratic, so therefore 3 points is enough. Okay, so this method they use symmetry. Okay, to find that third point. Okay, with 2 points you cannot get, but with the third point you can. Okay, other method that they suggested would be you get this first. So it's a bit on the calculus side. Okay, you know the equation is y equals to ax squared plus bx plus c. So you can differentiate this. So you get 2ax plus b yang ini lah. Okay, so the thing is you want the maximum to be at 4,6. That means at 4,6, okay, the dy dx is 0. Pasal maximum point means the gradient is 0. Okay, so you set this as 0, you get, you masukkan 4,6 and all that, you get 8a plus, okay, 8a plus b equals to 0. Okay, basically sini jadi 0. Okay, this one you masukkan 4 jadi 8a, okay, plus b. So 8a plus b equals to 0. Okay, then after this you substitute dekat balik ke sini. Okay, you substitute the second point that they give, the 7.50, masukkan kat sini. Okay, and then from here you use substitution and all that, you masukkan and all that, you should be able to solve for ABC. Okay, but that's a bit complicated lah. Okay, the first two yang I went through just now, okay, we use the completed square form, or you use the symmetry. It's much easier. This one is the more difficult way to do it. Okay, alright, what else? Okay, so that's the equation of the new model. Okay, so now the next one, believing this to be a better model for a cupcake, Charlotte finds the volume of the revolution about the x-axis. So they rotate the x-axis. Okay. Okay, so this part I'll run through a bit faster. So basically, kalau dia nak rotate, okay, the thing is, kita punya graph tadi, okay, dia ada this portion, okay, dengan the so-called curve depan. Okay, so you're rotating this, okay, against the x-axis. So dia ada dua portion, satu sini sama sini, okay, which you need to rotate. Lepas tu yang lihat tu is the curve. Okay, so the line and the curve. Okay, so when you integrate, you must show it as two parts. Satu, they integrate the line. Okay, use the pi, okay, and fx squared, or pi y squared, okay, dx. Okay, from which point to which point? From 0 to 4. Pasal the maximum is at 4, right? This one is 4, right? Okay, so from 0 to 4, you use the line integration. Okay, then from 4 to 7.5. Okay, 4 to 7.5. Okay, you're going to use the curve here. Let's call the curve gx. Okay, square dx. Ada pi kan? Okay, so this one is the fx. Okay, this one is the gx. Okay, this is the first portion from 0 to 4, pi fx square dx. This one is the second portion here from 4 to 7.5, pi gx square dx integrate. Okay, so they just ask for the expression, so you don't have to integrate them. Okay, just leave it as that. Okay, then the last one baru they ask you to integrate, and then you can use your EC, you'll get 501. Okay, kalau dah round off to 3 Okay, let's see. I think that's it. Okay, alright. So I'll put the video in batches. So this one is question number 4. So I will record again so that it's easy. You just see the question number that you want. Right? Okay. Thank you. Assalamualaikum.